Right, so I'm just going to give you, as I say, like a warm-up act. I'm going to give you a PowerPoint presentation on Unix, Linux, and the command line just to get you set up, and then I will hand over to Andrea, who will take you through the first stages of this. We will have breaks as well, and if at any stage you need to pop out or whatever, just feel free. This is not formal, it's just totally informal. And if at any stage you want to put your hand up, or you want to interrupt and say, sorry, I don't quite understand what you're saying, or you want to make an extra point, feel free to do that. You know, we're all among friends here, let's just be relaxed. So, what is Unix? So Unix is a family of what they call multitasking, multi-user operating systems. What that means is it's an operating system that runs on a computer that allows lots of things to go on at the same time, and it also allows lots of people to use the same computer at the same time as well. And these things started off back in the 1960s. So it's remarkable the staying power of Unix-like operating systems. They were started off in this place called Bell Labs. And what this operating system does, it orchestrates all the components of the computer and gets them working. It's like the grand conductor, if you like, of the orchestra there. So you've got the processor, the onboard memory, the disk drives, keyboards, monitors, and so forth. Get them all to use useful tasks. And it's accessed through what we call the command line interface. So this is on a terminal. So here's an example of a command line interface here where someone's logged into Unix. And you get a little flashing prompt, and you have a line, and you type your commands into that line. If you want to know more, Wikipedia's got quite a large, quite a good section on Unix there, and that's where I've drawn some of this material from. So after it starting off in the, I think it was a sort of mid to late 60s, in the 70s and 80s, Unix kind of evolved, and there became these numerous proprietary flavors of Unix, slight variations on a theme. And there was even this rather graphic term of Unix wars, where different flavors of Unix, different makes of Unix, if you like, were fighting with each other for market share and trying to get people to adopt them. And you had to pay for it if you wanted access. It was a licensed system. And then the world changed. In 1991, this guy, Linus Torvalds, created what he called Linux. He's actually a fairly modest man, and he didn't name the operating system after himself. One of his colleagues did that, but the name caught on. And what he created was something that was a free, open source Unix-like operating system. So for the user, it recapitulated all the features that you had in Unix, but it was free to use. And it's what we call open source, which basically meant that source code that powered the thing was freely available. So that meant that anyone who wanted to go and change it, fiddle around, make minor changes, could do so. And this is one of those things which, we should share good news, that one of the great things that goes on in bioinformatics, it is one of those things that makes you realize, that the human spirit is not always limited to being miserly and miserable and all that sort of stuff, is that people write software and they give it away for free. So Linus Torvalds did that. He said software's like sex, better when it's free. He gave his operating system away and changed the world in the process. And he'll be remembered to the end of time because of that. And what happened then was that various organizations took on the distribution of Linux operating systems. So they weren't allowed to, Linux itself was free, but they packaged it up in certain ways to make it easier. They might sell you a support package and so forth. So there were various distributions with minor differences between them. Things like Ubuntu, which is named after an African word meaning kind of togetherness, kind of communal working together kind of thing. Red Hat, Fedora, SUSE, and so forth. And this became very quickly the industry standard for all bioinformatics. I don't know, 90% more of bioinformatics is run on open source stuff running on Linux. When was the last time you used a proprietary piece of software?
Recently, actually.
Oh, okay, well, okay.
But the percentage is true,
Yeah.
especially in the DNA world.
Yeah.
So people doing mass spec are more prone to buy packages, but in our domain, we are thriving with free tools. Yeah.
The other this little penguin here is the symbol that's been adopted for Linux. I'm not quite sure what the history of that is, but you'll see that if you buy a book on Linux, you'll see that little penguin looking at you all the time. But independently of the Linux development, Unix evolved in its own way. In 2000, Steve Jobs decided that actually the Mac OS was going to go forward with a flavour of Unix. So he adopted this BSD Unix, and he came up with a core named Darwin. And he said at one of his presentations, you remember, you don't remember, you might know from history, he used to give lots of charismatic presentations with his roll neck sweater on, and one of the times he said, we're calling it Darwin because it's all about evolution. And he later this was later then built into the iOS that ran on iPhones. So Steve Jobs, he was supposed to be put it politely, a bit of an arsehole in terms of his personality and his private life and so forth, but he was a visionary because he was behind the Mac, he was behind the Mac operating system, he was behind iPhones, iTunes, iMovie, everything. Anyway, so Mac OS evolved from there on, and it's still, Mac OS is running Unix under the box. Android phones started running Linux since 2008, and most recently the Chrome operating system runs on Chromebooks is also another flavour of Unix, of Android I should say. So what's happened is that basically Unix has taken over the world, and so many computers, computational devices are now running on Unix. So the phone in your pocket, whether it's Android or whether it's an iPhone, is running on a Unix-like operating system. And most of what we're doing in almost all of what we're doing in bioinformatics is running on Linux, as I say. And embedded operating systems in all kinds of this Internet of Devices that's all running on Linux as well. So it's amazing the way this has taken over the world. So why on earth do you want to use these Unix-like systems? Well, the thing is that they're great for automation of computer tasks. They're very fast and efficient. So if you want to send a command that operates on 1,000 files, even 1,000,000 files, you can just do it with one line, and off it goes and does it. Very few keystrokes, and you can get a very complex series of things done. And as if in the history of microbial genomics, I'm old enough to remember when we used to work on one genome at a time. Then it was tens, then it was hundreds, then it's thousands. And you can analyze thousands of genomes in a single command and just get on with it. And I mentioned the kernel, which is the core of the operating system, and then there are the commands that interact with it. There are various utility programs and services and system configuration files. Now you're not going to get involved in all that kind of stuff. You're going to interact just with the command line, with the kernel using the command line. And this is just I just saw this on Wikipedia, and it just basically shows you how this thing kind of works out. You've got the Linux kernel there in the middle, you've got the hardware at one stage, you've got the human-machine interface, and then you've got all these kind of interactions going on to make this thing work. And as I say, you've got supercomputers, you've got desktop computers, mobile computers, wearable computers, embedded computers. All of this are running Linux-type operating systems. So how do you interact with it? So you use what we call a command line interface, where you explicitly type commands and have Linux execute them using a system called a shell. So what is a shell? This is actually a program that interprets those commands that you want to have executed by Linux. The default is often a shell called bash, and this is a bad joke by some informatician. I think decades ago. It stands for Born Again Shell. Can you remember? It's someone called Born wrote the shell.
Yeah, I think it was in the AT&T labs or something.
Yeah, and it was just a joke. It is. So this is a command line interface where you type commands in. If any of you ever bother to actually install Linux, you can do dual boots on your Mac if you want. You can install Linux. Most Linux distributions now do have a graphical user interface as well, so you can move files around using your mouse and stuff like that, using Windows and so forth. And there is a whole community out there of people who love using Linux as their default operating system, and they use the GUI. Do you do that?
Well, I can say that I worked for years for a company where everybody was using Linux. So from the managers to the DNA sequencing technicians, and it worked. So the fact that for business you need a commercial operating system is not completely true, and we could do our invoices and everything.
Yeah.
And we had, of course, the burden of managing our network, but also all the freedom that comes with it. So it's it is possible to do that.
And for most of the common things you want, there are open source versions that will run on Linux. So there's what's it called, LibreOffice. I think, is that the name of the latest version that runs? There was OpenOffice and then it became LibreOffice.
Sometimes the freedom means that people disagree on projects and they split. So
So there are various flavors, but they're all kind of clones of the Office suite of having a PowerPoint look-alike, a Word look-alike, an Excel look-alike, and so forth. All this is available and freely available for nothing. So if you compare the two different ways of interacting with the computer, so the command line, one of the burdens we have to say is that it does make you have to remember things. So you have to remember what the commands are, okay? And some of that becomes a burden. It's a sort of thing, and this is where I defer to Andrea, because I do this stuff rarely, and so I do have to warm my brain up and remember the various commands. I mean, the very basic commands you're going to learn today, I can remember those. But when it comes to doing a complex task, you have to remind yourself. But the trade-off there is that it's extremely powerful and versatile. And so last year, at the age of 61, I actually undertook a very large computer project where we wanted to create hundreds of thousands of names for bacteria, for bacterial species, and it required huge amounts of file manipulation. And I managed to do it. We ended up creating 65,000 new names for bacteria. And it's true, it's powerful and versatile. It's easy to write code for, so write in Python, easy to create pipelines. So this is one of the things you'll come across later, that you can run a command and then you can get the output of that command very quickly and easily just shoved into the next command and the next command, and you can create what they call a pipe, and everything can be just done. With the GUI, of course, you've got this intuitive, easy to use, but there is less power and versatility. It's harder to write programs, harder to write pipelines. And the bottom line here is the cutting edge is always with the command line. So if you want the latest program, you want to analyze nanopore sequences, let's say. Now, there may be some kind of program that works on a GUI that you could do it with, that some company has written for you and charges you $50 for or something like that. But that'll always be years out of date. The thing about the cutting edge is that it's people writing this stuff at the command. They release their stuff on GitHub usually. It's freely available. It's around the world in minutes from when it's been released, and people can use it straight away. And that's where you get the cutting edge. If you really want to use things up to date and do the best way of doing things, you have to put that investment into using the command line. Is there anything else you wanted to say about the benefits of Linux?
They will
You'll feel
by
it
the end
tangibly.
of the week, I hope.
Yeah, exactly. No, so there are some faffy things, that are a bit annoying, but once you get used to them, you can see them as useful as well. So when you're issuing commands and you're using file names as well, in the Linux system, it's case sensitive. So exit, if you type exit with a capital E, it's a different command from exit with a small e, bow tie gate and gate and so forth. Another thing, probably not many of you have actually bothered to actually look at the Windows directory structure, but there's a difference in Linux. You have the / as your separator, whereas unlike Windows, which has, or DOS as it used to be in the old days. And Linux file names, you can call them whatever you like. Smelly old sock. If you want to call it smelly old sock, you can call your file smelly old sock. Doesn't make any difference. And unlike Windows or the Mac operating system, when you're using it as the GUI, you don't actually have to have a file extension even. Generally, people do use file extensions, so they put a dot and then put typically a 3-letter file extension. But you don't have to. And one other feature that you find when you're using the Linux system is it will not tolerate spaces in the names of files or commands. And so what you quickly end up doing, people use the underscore as a way of marking a space and to separate words. And I tend to do it now even when I'm just using my Mac and saving files. It just kind of get used to putting underscore. It becomes the default as a way of marking gaps between words. So, if we wanted to save Darwin's origin of species, origin underscore of underscore species dot text, and that would work fine. So when you're using Linux, you're using applications, programs that you're going to run, and you're running those typically over files. And there are different kinds of file types in Linux as well. So when you're looking at the kind of data files, you can have basic text files, or you can have what we call binary type files, where you can't just open them as a text file and see what's in them. There's a certain kind of encoding goes on. And then there are what we typically call programs. They're called executable files in Linux, and so programs like bow tie gate, ls, cd, blah blah blah. So I've said that there are some problems. You've got to remember these commands and so forth. But one of the things that's quite liberating is that all the commands basically have the same form of structure here. So you issue a command, tell your computer to do something. So you just type in the command name. There then will be various options that you can just. There will be a default, so you just put the file that command name in on its own, and it will usually still run. But if you want to change it, you can say, I want a more complex output, or I want you to change the settings in this way or that way, and then you have arguments. So those are the things that you're acting upon. So what files are you? What's going to be your input file? What's going to be your output file? Often, and so we'll be doing this in a moment. But you type in a command like ls. So many of the basic commands in Linux and Unix are actually just very, very abbreviated English words. So ls actually stands for list, and it lists the contents of a directory. And if you put this option with a -L, which L stands for long, it gives you the long form, so it will give you a lot more detail than you get if you did the default. And then this argument /temp here, this is the name of a directory, and so it's showing you the contents of that directory. This is better if we show you rather than tell you, but I'm just laying the groundwork. You'll be doing this again yourself soon. One of the funny things that happens is when you issue a command, the program, the operating system just goes off and runs that command. And it doesn't often, often it won't give you any feedback and say, oh, okay, I'm running this command, I'll come back in half an hour or 2 hours or whatever. It just goes off and does it. And sometimes you find yourself in a situation where you've issued the command and you think, oh, I didn't want to do that. Oh, it's running the command over 100,000 files. I only want to do these 10 in this directory. Oh my goodness, how do you stop? So there is a way of just saying stop, put on the brakes, you type Control-C or Control-Z. Another thing, and we're going to go into more detail about this, you know, if I say the same things as Andrea then says to you later, that's not repetition, it's reinforcement. We're going to keep saying these things, some of it will stick. But one of the issues is that you, in the Linux system, files belong to users, to groups and so forth. And you may not have the ability to actually run a file or run a command as yourself, but if you're the super user that controls everything on the computer, you may have. And there's actually a quick, this is a joke that I found. There's a command called sudo, which stands for super user do. So if you type sudo in front of the command, it will ask you, oh, okay, you think you're the super user? Give me your root password. So on your Macs, you are root, you have root access, so you can just say sudo and it'll put in your password and then it'll do it. So here's their little joke, you know, you can say someone make me a sandwich, no, go and make it yourself, and then sudo make me a sandwich. The operating system has to do what you say because you're the super user, and off they come do it.
A really simple question.
Yeah, sure.
When you say type Control-Z or Control-Z, does that mean on the keyboard?
On the keyboard.
Or do you type the words out?
No, on the keyboard. So that control key on the Mac keyboard is down there on the bottom left of your keyboard. You hold that key down and you hold down the C or the Z. And that will...
If it was like typing it out?
No, you don't have to type out the whole thing. No, it's just holding those two keys down at the same time.
Thank you.
And anyone else who has any questions, if anything is not clear, just say, because we realise you're total beginners. And it might surprise you that I can still remember the first time I did this. It's a bit like the first time you stepped in the car and tried to drive it away. You know, it's like, wow, what am I doing here? So don't, you know, it's perfectly acceptable for you to feel a bit all at sea at the moment or stressed out. So using the terminal, and again, I'm going to pass you over to Andrea in a minute, and we're going to do this. But the thing is, on your Mac, Windows people, can we give her the Mac then?
Yeah, or Linux. It's a native.
All right, whatever.
Is
So
there a way of checking if it's got Linux on?
it won't have Linux on as a default.
Okay.
You can log on to a remote machine using Windows, but today we're going to just be using our the machine in front of us, so it's probably easier if we just give you a Mac and you can play with it for a while. I mean, you can probably get a terminal app for your phone, actually. I mean, on Mac, on iOS, you can basically interact with the operating system with a terminal app, even on your phone, but that's probably a bit too much. So the great thing about Macs is that the whole thing, all of that graphical user interface is actually sitting on top of the command line interface underneath. And you can interact directly with that command line interface with a program called Terminal. And if you go to that window that opens up all your programs and you scroll around, you'll find there's a little directory called Other, and in that directory called Other you will find Terminal. Probably what you want to do is to pull that out and put it in the dock, so it's available for whenever you need it later on. One of the things I haven't asked, how many of you used Macs before you came? How many hadn't then? And how many of you are finding it a steep learning curve just using the Mac? Okay, right. Well, we made this decision. I mean, I've used the Mac operating system for decades. But I appreciate that some people, some people like Mozart, some people like Beethoven, don't they? It's just, I think the Mac operating system is much better. But
Totally agree.
Huh?
I totally agree.
But I know that there are people who are equally passionate, and we can have that debate. What I will yield on, coming back to what I said earlier, Steve Jobs, I think he was a genius in terms of the products he produced, but he was a complete arse, and he did nothing else to save the world. Whereas Bill Gates has, he built an inferior operating system, but he's used his millions to cure the world of malaria and many other activities that make the world a better place. Anyway, we're getting off topic. Terminal, use the terminal. There we go. So once you click on terminal, you'll get a window open up like that. That's the default. For those of you who like to play around with things, you can actually change the look and feel of it. You can change what font it's got, what colour it has as the background, what colour it has as the text, and so forth. But this is the kind of prompt you will get. I'm going to finish soon because I'm going to pass over to the master. As I say, I'm John the Baptist. This is the Messiah. So the Linux file system is hierarchical. Okay, it resembles a tree. So at the top is what we call the root directory, which is just this slash, and then underneath it are these directories that sit within it, and then within those are directories that sit within them. And what we have is this so-called absolute and relative file path. So when you want to describe a path when you want to describe a file, you can either just call it by its relative path. So if you were, when you're at the command line, you're sitting somewhere in that hierarchy. You're in a working directory. There's actually a command called pwd, print working directory, which tells you which directory you're in. You're in that directory, and if a file is within that directory, you can just type the name of the file and it'll see it. So if we were in that directory admin there and we typed the file Steve, it would find it. But if we were elsewhere, say we were up in bin and we wanted to address that file, we would then have to put in the absolute file path of /users /admin /Steve to get to it. As an extra kind of add-on, you can actually use these approaches that take you up and down directories as well. So if you were in admin and you wanted to address the directory users, you could just type the absolute file path of /users, but if you put ... that is a command that says look at the directory above this one in the hierarchy. So it takes you up one step. Now all of this is, I'd say it's like learning Welsh or learning Chinese. It's all going to be but this will all become second nature to you in a very short time. What I was going to do is print this out. I forgot to do it. I didn't get around to doing it. But I'll print out this cheat sheet, and we can give that out to you as well, so you can have that in your hand. There's no shame in actually having the cheat sheet and looking at it as you get started. If you're particularly keen to learn more, you can buy one of these O'Reilly guides or these little books that have all these commands in. They're useful to get yourself started. And I'm nearly finished now. When you're working on a Linux computer, you can run it on your personal workstation, so basically your laptop or a desktop machine. But what we often do is we run it on a server, which is the kind of thing that's been set up for multiple users to use the same hardware at the same time. And tomorrow we're going to be logging into a server, but I'm just setting the way for you. And what we need to do when we log onto a server is you'll have to have a username for that server, a password, and then you have to have the address of that server. And we will be using the terminal on your Mac to connect you to a server tomorrow. When you do that, you basically connect to that server, and you're just connecting through the command line. So typically you won't be allowed to display any graphics. So if you want to start drawing graphs and stuff on the remote server, you can't just do it straightforwardly through the command line, but there are workarounds to do that as well. And as I've said, Linux is typically the flavour that runs on virtual machines. So today, you'll be using the Mac OS, which is a flavour of Unix. But from tomorrow and onwards, you'll be running Linux on your virtual machines that we use as servers. Now, I can see from the body language that some of you are kicking back, I hate this already. Everyone hates this, and there are a few quotes that people... I've got this book at home, and I meant to bring it in. I forgot to put it in my bag. But, people actually wrote a book called Unix Haters Handbook because they hated it so much. There's a young woman she's adopted the stage name of Linux, and her first album was called Everybody Hates Linux, and there's a song called Everybody Hates Linux. And here are some of the quotes that people have put out there about Unix and Linux. The two major projects, LSD and Unix. We don't believe this is strictly by coincidence. You have to be pretty spaced out to think that Unix is a great thing. It's not designed to stop you doing stupid things, because that would also stop you doing clever things. So there's a command. Don't ever type this command, which is rm ****. If you do that, it will delete everything in your directory. It'll wipe. If you're on the root directory, it'll just wipe your directory clear. And as I said before, the operating system gives you no feedback. It just says, "All right, you want me to do that?" And off it goes and does it. So if you ever type, and they say an expert is someone who's made all the mistakes that can be made in a narrow field of knowledge. I have once typed rm **** because I thought that I had Dropbox working on a Linux box, and I thought, oh my goodness, no, it's going to start syncing my whole Dropbox folder, gigabytes of stuff, and I don't want that. I just want to synchronize a few files. So I typed rm *** within the Dropbox directory, and then I realized it was deleting my entire Dropbox. Every file I had, gigabytes of data, were suddenly destroyed, not just from that Linux box in front of me, but from my whole Dropbox. And luckily Dropbox has version control, but I spent at least an afternoon getting back all the files and directories. So one little command that took seconds to issue took me hours and hours of, and basically my heart rate must have gone through the roof, the anxiety of losing every file I'd ever created. Unix is user-friendly. It's just picky about who its friends are. Anyone get that little joke in the bottom there? There's no place like home. That little tilde sign is a symbol for your home directory. It'll always take you to your home directory. And just a final point there was this philosophy in the early days of Unix, which they actually called it worse is better. They said it's not, this program's worse than the last one. That's not a bug, it's a feature, because, we're making it more focused, it does less things, and this, you kind of think that's a strange philosophy to think that worse is better. So these people are a bit mad. Here's a few commands that you could type at your leisure later on today. I'll share the PowerPoint file with you, but if you type all these things into your command line, when you get a bit bored and Andrea's been prattling on for too long, type one of these in and see what you get as a bit of fun. The thing is, you can open up multiple terminal windows, so you can open up a terminal and do this while you're also doing something serious if you want to. And that's it. That's me finished. So, anyone got any comments or questions at this stage?
Another potentially very stupid question.
Yeah.
What do you mean by directory? Just as like a definition.
Well, so a directory is effectively the same as a folder. So if you're used to using any GUI, like Windows or Mac operating system, and you have a folder, a directory is just a synonym, really. So it within the file structure, you have directories within directories within directories. It's just a way of keeping your files in order.
Okay.
And there's no reason. I can't remember. I think the Unix would allow you to have certainly hundreds of thousands of files in the same directory on it. Is there an upper limit on how many files you can have in a directory?
It depends on the file system.
Yeah, but it's if you just want to be untidy, you could keep 100,000 files in a single directory. But most of us, when we're dealing with projects, we like to keep things in an orderly fashion. So it's just a way of keeping things in place, so a place for everything and everything in its place. Nothing
Especially
more.
shared servers where someone else set up the structure,
Yeah.
and so you have permission to work in your, I don't know, research group directory.
Yeah. Well, the other thing is also that a lot of the time now you are working in a group. This is one of the things we can talk about later in your PhD, that there's still this old-fashioned view that a PhD is the loneliness of the long-distance marathon runner, that you are, just you working on your own, addressing a single topic. That's never true now. You're always working as part of a group, and when you're sharing stuff with someone else in the group, it's much better if everything's in a nice, tidy, user-friendly file structure. So, that's where you've saved the salmonella genome files, and as I said earlier, you can call it smelly old sock if you want, but if you say, salmonella genome 53 or whatever, it makes it a lot easier for someone else to pick up your work later. So, although there is that tremendous freedom, you don't generally use it. Okay.
You can constantly make parallels between the wet lab and the dry lab. There are people labeling their Eppendorf A, B, and